Howdy, everybody. I did get a chance to work on kdenlive the past couple weeks. I just didn't get a chance to stream. Did not have a good opportunity. The kdenlive work is getting OpenGL filters working on kdenlive, which is a large part of just managing OpenGL contexts, or in this case I'm just going to call it acceleration resources for MLT. MLT kind of delegates to the application to do so. I think it's missing one or two things, but for the most part it just delegates to the application, and kdenlive, being an application that uses MLT, needs to ensure that the OpenGL context is appropriately established before requesting rendering that might require OpenGL, which unfortunately is pretty broad. It just means that anytime MLT get frame, such as here, is used, it may mean that the producer, the MLT producer in question, might be a pipeline that uses Movit or OpenGL operations, so it needs an OpenGL context. So I've established a singleton manager called acceleration manager, which provides a method, acquire context, which provides a scoped Excel context that is set up such that this can be called pretty much anywhere in kdenlive, and it'll return a valid context for using MLT getFrame. This is also used by the GL widget, which sets up the MLT consumer, so its threads always have a valid OpenGL context. And that's what we're looking at here. This is part of the API that MLT delegates to the application, which is threads, and MLT provides an M function for what the thread should compute, and delegates to the application actually running that thread. And here we use that to establish an OpenGL context or an acceleration context, and when this scope is closed, this Excel context goes out of scope, which indicates to the acceleration manager that the context is no longer needed. So this ends up working just fine. I'm not super happy that there is this requirement that anytime you call getFrame, you need to make sure that a context is established. In the code base, there's no real clean guarantee that we can always intercept getFrame. So I kind of had to search through the code base to find all instances of getFrame and evaluate whether they applied or they needed this acceleration context or not. In addition, I did some consideration in acquire context to ensure that it's always safe to call acquire context. The initial version of this worked fine, except for it always produced a new context when required, and that was rather expensive. It worked, but it was expensive. This variant uses, right here, a qthread storage, mthread cache, to store Excel thread cache instances, and this Excel thread cache contains a valid OpenGL context to be used for MLT, or more accurately, it contains all the acceleration resources in use by that thread. This meant that in some of these cases, such as clip controller, which is generating a qpix map of any clip at a given frame position, even though that this is evaluated many times in a single thread, instead of acquiring a new context every single time, it actually acquires the same context, and it doesn't actually even need to change the context in that case. You might say, but you're using thread local data, and thread local data is somewhat problematic to some people. In this case, qthread storage is an excellent interface over thread local data, and that's not too critical because the entire OpenGL context is a thread local data. So we're already committed to using thread local data at that point. In fact, Qt uses thread local data behind the scenes to manage its own context information. And this worked. I can't show it because every time I start up kdenlive, it kills my Pulse audio recording. But it works, and I can edit videos and add OpenGL effects, and no crashes related to that. It does, however, assume that the OpenGL provider supports multi-threading, and that, according to the existing code, is not always guaranteed. I did structure this to enable consideration of only on-screen contexts and have it behave appropriately even in those cases, either by failing fast if somebody truly is trying to do multi-threaded OpenGL on a system that doesn't support multi-threaded OpenGL, or just establishing the on-screen context if that's doable, such as a request on the main thread. So that should work for supporting all the modes expected by kdenlive for GL acceleration. What I haven't covered here is rendering of kdenlive or MLT timelines. As far as I understand, that does require an OpenGL context if you're going to be rendering videos that use an OpenGL filter. However, I haven't actually tried it. I don't actually know what happens. I don't even know if there's already consideration of instantiating an off-screen context within MLT for those cases. No idea. So that would be one thing to try before I push this upstream to kdenlive. But progress is good, and pretty happy with the solution so far. Strikes a nice balance between supporting what is currently there and pushing towards cleaner management of resources. Last I left off, I was getting stuck on adding a custom deleter to a unique pointer. That didn't end up being necessary or even a good idea at all. Ended up having to create a data class Excel context holder that associated its constructor and destructor with various operations beyond just a simple call a function on an existing object in the unique pointer. Hopefully you guys found that interesting, and I will include a link to this code that I'm talking about down below. And as I make progress on this, make another video. Until then, later.